In this lecture, we are going to learn about conformal mappings and its standard transformations. Introduction. Suppose we have two curves, say C1 and C2, in the Z-plane, intersect at Z0, and the corresponding curves gamma 1 and gamma 2 in the W-plane intersect at W0 by the transformation W equal to f of Z. If the angle between two curves in the Z-plane is same as the angle between two curves in the W-planes, both in magnitude and in direction, then the transformation W equal to f of Z is called as the conformal mapping. So we can see in this graph, C1 and C2 intersect at the point Z0 in Z-plane, and W-plane, in W-plane we are having gamma 1 and gamma 2 which is intersecting at W0. So in Z-plane you are going to have the complex variable as Z plus Iy. Therefore you are having x coordinate and y coordinate, and this transformed into a W-plane by f of Z, okay, which is nothing but W. So f of Z, you know that it is having u plus iv. Therefore the coordinates are u and v. So here the transformation mapped onto W plane with same magnitude and direction. If there is no difference between the magnitude of these two curves, okay, reflection, and there is no difference in the direction, orientation, then you can call that transformation as conformal mapping. So the definition says that the transformation that preserves angles between every pair of curves through a point both in magnitude and sense of rotation is said to be conformal at that point. So you can say that the function is conformal at the point, say Z0, if it preserves the same magnitude and direction at the point W0 in W plane. Now what do you mean by isogonal transformation? Isogonal transformation means the transformation which preserves angle between every pair of curves in magnitude but not in direction. But not in direction is called isogonal transformation. Now you can see the example of this. F of Z equal to Z bar is an isogonal mapping. Why we are saying it as isogonal mapping? We know that Z equal to x plus Iy. So what is Z bar? Z bar is x minus Iy. Therefore, it preserves the magnitude, okay, and it is having different direction, okay, angle in both magnitude and different. Here you can see this, the angle for f of Z equal to Z bar, it is in the opposite direction. Therefore, it is an isogonal mapping. Okay, it preserves angle between every pair of curves in magnitude alone, but not in direction. So this, okay, Z bar does not preserve angle in direction, but it preserves angle in magnitude. Therefore, it is called as an isogonal transformation. Now, the theorem says that if f of Z is analytic and f dash of Z is not equal to 0 in a region R of the Z plane, then the mapping performed by W equal to f of Z is conformal at all points of Z. So, here the derivative of f of Z does not fails to, okay, be analytic. F of Z is analytic means what? It is having the derivative at a point Z equal to Z0, not only at that point, around the neighborhood also. Therefore, conformal means it fails to be analytic. Okay. So, here f of z equal to sin z is a conformal mapping at the point z is not equal to n pi. We'll see that. How it is not equal to n pi? Because you have find f dash of z. F dash of z will be cos z. When this cos z equal to 0, f dash of z you will get it as okay. So f dash of z is going to be cos z. Now conformal means what? F dash of z is not equal to 0. Okay. When this f dash of z is equal to 0, that means cos z equal to 0. Okay. What is the value of cos n pi? Minus 1 to the power n. Okay. Minus 1 to the power n. Okay. What is the value of cos pi by 2? This is 0. Okay. So, here they are saying that f dash of z is not equal to 0 means when it is not equal to 0, when z equal to, when z is not equal to n pi. When z equal to pi by 2, we are getting it as equal to 0. That's why they are saying that f of z equal to sin z is a conformal mapping at z is not equal to n pi. Hope you understood. We'll move on to the next concept. Critical points. What is meant by critical point of f of z? Critical points means the point at which the mapping is not conformal. So what do you mean by conformal mapping? Conformal mapping means f of z is analytic and its derivative is not equal to 0. Critical point means what? F of z is analytic and its derivative is equal to 0. So you can consider the example w equal to f of z which is equal to sin z. The example which we have seen earlier. F dash of z equal to cos z. So f dash of z equal to 0 implies that cos of pi by 2 is equal to 0. We know that cos of minus theta is cos theta. So cos of minus pi by 2 is also equal to 0. Then cos of 3 pi by 2 equal to 0. Cos of minus 3 pi by 2 equal to 0. Likewise it goes off. So you can take it as z equal to, in generalized case, z equal to 2n minus 1 by 2 into pi, where n is an integer. N is an integer means you can put n equal to 0. When you are putting n equal to 0, you are going to have z equal to minus pi by 2. Then put n equal to 1. By putting n equal to 1, 2n minus 1 will give you 1 into pi by 2, so plus pi by 2. When n equal to minus 1, put n equal to minus 1, minus 2 minus 1, so minus 3 pi by 2. Put n equal to 2, what you will get? 4 minus 1, so 3 pi by 2 plus 3 pi by 2. Likewise, you can check out all the other points. It is coming like this. That's why we are having n as an integer. Therefore, sin z is a critical point. The critical points of sin z are, okay, z equal to 2n minus 1 into pi by 2. Now we are going to see standard relations, standard transformations. First is transformation is translation. So translation means the function in z plane get transformed into z plus k in w plane, where k is a complex number. Okay, the function in z plane get transformed into z plus k into in w plane. We'll see the example based on this. Find the region of the w plane into which the rectangular region in z plane bounded by the lines x equal to 0, y equal to 0, x equal to 1, y equal to 2 is mapped under the transformation w equal to z plus 2 minus I. So we know what is z and what is w. We know that z equal to the complex variable in z plane x plus y and w equal to the complex number in w plane u plus iv, that is image of z. So w equal to u plus iv and z equal to x plus iy, then 2 minus I. Separate the real and imaginary part. You will get u plus iv is equal to x plus 2 plus I times y minus 1. So the real part is going to be x plus 2 and the imaginary part is y minus 1. Now they have given the lines in z plane x equal to 0, y equal to 0, x equal to 1, y equal to 1. Substitute all these points here. You will get the image of z plane in w plane. Okay. So when x equal to 0, you know that u equal to x plus 2 and v equal to y minus 1. So when x equal to 0, you are getting u equal to 2. When y equal to 0, v equal to minus 1. When x equal to 1, u equal to 3. When y equal to 2, v equal to 1. Therefore, if you are drawing the graph for this, you will get x and y axis. Okay, x equal to 0 is this line. And this is x equal to 1. This line is y equal to 0 and this line is y equal to 2. Now you can see that it is a rectangular region in z plane. Now how it is get mapped onto a w plane? In transformation w equal to z plus 2 minus I. Z plus 2 minus I, we are getting u equal to 2. Okay, this is u axis and this is v axis. U equal to 2 is a straight line passing through the point, okay, 2 comma 0. Then u equal to 3 is a straight line passing through the point 3 comma 0. Then v equal to minus 1 is a straight line passing through the point 0 comma minus 1. And v equal to 1 is a straight line passing through the point 0 comma 1. Now you can see that the bounded region is this rectangle. So you can observe that in the z plane you are having the rectangle and the w plane also under this transformation you are having the same rectangle size. So under the translation we can observe that there is no change in the shape, there is no change in the size of the image, but this rectangle is moved to a distance of unit 2. This rectangle in W plane under this transmission, it is moved to a distance of 2 units. So this is a transformation. Okay. So first we have to find out what is Z and what is W, and you have to separate the real and imaginary part. Then you have to substitute all the lines, whatever they have given in Z plane, to find out the image in W plane. Substitute it here. You will get the lines u equal to 2, v equal to -1, u equal to 3, v equal to 1. By drawing that in W plane, we can able to observe that the rectangle in Z plane is mapped onto a rectangle in W plane. There is no change in the shape, there is no change in the size, but there is a displacement. This rectangle gets displaced 2 units in W plane under this transformation. Hope you understood. Now we'll move on to the next transformation called magnification and rotation. So in Z plane, Z get magnified k times Z in W plane, where k is a complex constant. We'll see the problem, how we are having the changes. Now here let us take W equal to AZ, where A is not equal to 0. If I am taking the polar form of Z and constant, you will get A equal to modulus of A into e power I alpha and Z equal to modulus of Z into e power I theta. That means you are considering the radius. So modulus of A into modulus of Z into e power I times theta plus alpha equal to W. The image of Z is obtained by rotating the vector Z through the angle alpha and magnifying or contracting the length of Z by the factor modulus of A. So, this transformation W equal to AZ is referred to as a rotation or magnification, or you will have both. So, example of magnification, consider this problem. Determine the region R of the W plane into which the triangular region D enclosed by the lines x equal to 0, y equal to 0, x plus y equal to 3 is transformed and the transformation W equal to 2z. Here I said that A can be a complex constant. Here A is the real constant. Real number alone we are having. So here you are going to have only the magnification. Let us consider W equal to U plus IV, Z equal to X plus IY. Then substitute it here, separating the real part and imaginary part. You will get 2x as real part, 2y as the imaginary part. Then x plus y will give you u plus v by 2. Now you are going to find out the image of x equal to 0. So u equal to 0. Image of y equal to 0 will give you v equal to 0. Image of x plus y equal to 3 gives you u plus y equal to 6. Now as a conclusion, you have to show this diagram. You can see this. X equal to 0 is y-axis, y equal to 0 is x-axis in Z plane, and x plus y is equal to 3 is line joining the intersecting point 0, 3 and 3, 0. So this is x-axis, this is y-axis. Now under this transformation, w equal to 2z, you are having u equal to 0 is v-axis and v equal to 0 is u-axis. Then u plus v equal to 6 means it is a straight line joining the point 6, 0 and 0, 6. So you can observe that it is a small triangle here, but here the size is 2 times bigger than the original one. So under this transformation w equal to 2z, it get magnified 2 times. Hope you understood this problem. Therefore, the image of triangle in Z plane is mapped onto the image of triangle in W plane, but it gets magnified. So what we can conclude in this magnification under W plane, conformal transformation, you can say that under magnification, you are going to have same shape, but sizes get magnified. There is no change in the orientation also. There is no change in the orientation when you are considering A as a real constant. Now we'll move on to the next example. Consider the transformation W equal to e power I pi by 4 into Z and determine the region in the W plane corresponding to triangle region bounded by the lines x equal to 0, x, y equal to 0, x plus y equal to 1. So you can observe here, you are having e power I pi by 4. We know that by Euler's theorem, e power I theta is cos theta plus I sin theta. So in the place of theta, you are going to put pi by 4. Therefore, W is, we know that u plus iv into e power pi by 4 into x plus iy. We are getting cos pi by 4 plus I sin pi by 4 as e power pi by 4 into x plus iy. Separating the real and imaginary part, you will get by writing the value of cos pi by 4 and sin pi by 4 as 1 by root 2, you will get x minus y by root 2 plus I times x plus y by root 2. So the real part is x minus y by root 2 and the imaginary part is x plus y by root 2. Now, for these bounded lines, we are going to find out the image of u and v. So when x equal to 0, okay, when x equal to 0, u equal to minus y by root 2 and v equal to y by root 2. Therefore, you can write it as y equal to minus root 2 into u and y equal to root 2 into v. Since the left hand side is same, you can equate these two. You will get minus 2 root u into root 2 v. Root 2 gets cancelled. You will get u equal to minus v. Or you can write u plus v equal to 1. Then, when y equal to 0, what is happening here? We'll check it. U equal to x by root 2 and v equal to x by root 2. Therefore, u and v are same. So, you are going to have u plus v equal to 1 when x equal to 0 and u equal to v when y equal to 0. Then when x plus y equal to 1, when x plus y equal to 1, what is happening? So here, you have to put x plus y equal to 1 means from this you can able to write Okay, by solving it, you will get x minus y equal to root 2 into u, and x plus y equal to what? Root 2 into v. So, x plus y equal to 1. Therefore, x plus y equal to 1 implies that v into root 2 equal to 1. Therefore, v equal to 1 by root 2. Like this only, we are getting this v equal to 1 by root 2. Now, we have to plot these lines in the w plane. So, in z plane, we are having y equal to 0, x equal to 0, and straight line joining the points 1, 0 and 0, 1. That get mapped onto w plane as w equal to what? E power I pi by 4 into z. So, under this transformation, we are having u plus v equal to 1. What is u plus v equal to 1? It is a straight line joining the points, not u plus v equal to 1, u plus v equal to 0. Okay. So, u plus v equal to 0 or u equal to minus v. Okay. We know that u equal to plus v is a straight line passing through the point 0, 0 in this axis. Okay. So, u equal to minus v means here when u equal to 1, v equal to minus 1. Okay. When u equal to 0, v also equal to 0. When u equal to 2, v equal to minus 2. When u equal to plus 1, v equal to, u equal to minus 1, v equal to minus 1. You can see it here. Put it here. U, v, minus v. So, u comma v, u comma minus v. 0, this is u equal to v. Then this is u equal to minus v. So, 0. This is also 0. This point is 0, 0. This point is also 0, 0. Then when u equal to 1, v equal to 1, u equal to minus 1, then here it is going to be what? U comma v is 1 comma 1 and here it is 1 comma minus 1. Then 2 means you are going to have v equal to 2, here it is minus 2, here 1 comma 2 and then 1 comma minus 2. By joining the points like this, you will get u equal to v is a straight line passing through this axis and u equal to minus v is a straight line passing through this side, okay, opposite side, and v equal to v equal to 1 by root 2 is a straight line passing through the point, okay, 0 comma 1 by root 2. So, you can see that the bounded region is this green portion. Therefore, under this transformation, this triangles get transformed into a triangle only, but it get transformed into magnitude as well as in direction. Magnitude as well as in direction. So this moved like this direction. Okay, you can see it here. In previous case, you are having like this. Here it will get tilted like this. Okay. So this is the example for magnification as well as rotation. Hope you understood. Therefore, the mapping W equal to Z into e power I pi by 4 performs a rotation of R through an angle pi by 4. Okay. Thank you all.